Hi, everybody, and welcome back to Chapter 5, video number 4. Here, when we left off, we were looking for solving for unknown interest rates. And we're going to assume that Amazon needs $1,070,584 5 years from now to purchase electric scooters for employees in their new headquarter 2 location. They currently have $800,000 to invest. They want to know what kind of interest rate it's going to take for them to get there. So now we know the number of periods, 5 years, and we know the present value and the future value, but we don't know interest. So what does that look like? We're going to take the future value that we want divided by the present value that we have, and we get 1.33823. And so I look that up on the schedule here, and that says I'm going to need a 6% interest rate to hit that, right? So here, we could do it the other way. We can take it where we take the present value divided by the future value, we get 0.74726, and again, it's going to reflect the same thing. 5 years, 6% to hit that number of 1,070,584. All right. Now, Vince's store is considering the following time value of money scenarios. Using the appropriate interest table, answer the question for each scenario. And there's several of them here. Each case is independent from the other. So I'm not going to read all of these, but let's just look at the first one first. What is the future value of $7,000 at the end of 5 years at 8% interest compounded annually? So A is pretty easy. We're going to take 7,000 times, look up 8%, 5 years on table 5.1, and we get 1.46933. Multiply it times 7,000, we get 10,285. In the second example, what is the present value of $7,000 due 8 periods from now, discounted at 6%? All right. 8 periods from now. So we're going to go and do the same thing. We're going to go look that up in table 5.2, and we get this 0.62741. That's 8 periods at 6%. Multiply that times 7,000, and the present value of that would be $4,392. All right. So now Vince needs to accumulate $1 million for future expansion plans. The company's money market fund has a balance of $92,296 and has a guaranteed interest rate of 10%. How many years, with of course annual compounding, must Vince leave that balance in the fund to get his desired $1 million? So we can do this a couple of different ways, and it can be solved either the future value or present value approach. So the number of interest periods, then we're going to divide 1 million by 92,296, and that's 10.83471. So a dollar would accumulate to 10.83471 during that time. So that factor here, or its approximate, is then located in the future value table, 10% column, and the 25 period line. I'm going to check that, future value table 5.2, and the 25. Ooh. 25 period lines. What did I say, at 10%? And it looks like that number is going to be 12%. So 12% is the interest rate Vince must earn on the investment to accumulate that $1 million. As I can say, you can either use the future value or the present value approach. Okay. All right. Solving for the future value of an annuity and the annuity due problems. Here we have, did I miss one there? Yeah, we're good. Okay, solve future value of an annuity. The annuity requires periodic payments or receipts, sometimes called rents, of the same amount. The same length interval between such rents, so let's say a year or semi-annually, and it's going to compound once each interval. And there's two types: an ordinary annuity, that's where the rents occur at the end of each period, right? And but sometimes the rents occur at the beginning of each period, a month paid in advance in a way. All right, so here we go. Here's the present value, and this is an ordinary annuity. You can see that it's starting in period 1. If it was a annuity due, it's going to start at period 0. But here it's not. So I've got 1, 2, 3, 4, 5, 6, 7, 8 periods, right? Now, here's what we do. We'll solve for the future value. Assume that we deposit $1 at the end of each 5 years. We're going to go look. We could do this individually, right? By calculating these from table 5.1, right? And we'll get a value of 5.52563. And if you look at that in table 5.3, I do believe, let's make sure I'm not lying to you, 5.3, 5 years, 5%. And that's exactly what you'll see. 5 years, 5% in table 5.3, you'll get this same number that's calculated for you. But you could have calculated it individually by adding these amounts from table 5.1, and that's how you would calculate it manually. So now a formula provides a more efficient way of expressing that, if you think that's efficient. So here's our rent, our amount, and here is the future value factor. Here's the interest rate and the number of compounding periods. So if you plan to make $5,000 deposits made at the end of each of the next 5 years earning 6%, you would take this same factor that we just calculated, 5.63791, multiply it times 5,000. That's the annuity, as shown here, 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 and here. And you're going to have $28,185.45. Now, you planned the same thing here. What is the future value of those 5 deposits? Again, what table do we use? Much easier, just to jump on to table 5.3. Pick up that factor, future value of an ordinary annuity here, and we get that same number. That's how you want to solve these problems in the textbook. Okay, so let's take a look at Hightown Electronics here. Hightown deposits $75,000 at the end of each 6-month period for the next 3 years. to accumulate enough money to meet debts that mature in 3 years. What is the future value that Hightown will have on deposit at the end of 3 years if the annual interest rate is 10%? So these are every 6-month period, so that's 6 semi-annual periods, which is shown here. But we're going to be using an interest rate of half of 10%, which is 5%. What table do we use? And hopefully you know by now, it's going to be table 5.3. And here it is, table 5.3. And we're going to go look in the 5% column for 6 periods. It gives us a factor of 6.80191. We'll multiply that times $75,000. And that means our future value will be $510,143.25. Okay, so this is a little different with annuity due. Here, you got to be a little alert to the fact that rents are going to start at the beginning of each year, right? So it's easy to lose track because this goes from 0 to 7, which is 8 periods, right? But it starts in period 0, which is now. Okay, so the interest is going to accumulate during the first period. So same as before. This time, we are going to go to calculate that. We're going to add these guys together, and we get ordinary annuity here is going to be the 6.35285. But for 5 periods with it, annuity due, it's going to be 7.11519. So I do believe that we do have a table 5.4. Let's see if we do. And this is going to be okay, 7.11, that's fine. Here's 12%. Yeah, I guess we don't have that. They did comply. How many periods was this? 8. Okay, what did I say that was? 12. 6%. Okay, no table provided. All right, let's take a look at that. Sue Latido plans to deposit $800 a year on each birthday of her son Howard. She makes the first deposit on the 10th birthday at 6% interest compounded annually. What amount will Sue have accumulated for college expenses by her son's 18th birthday? So she made this on his 10th birthday, so she has, I guess, 8 more years to go. So she's going to put $800 a year, every year, 6%. So that's the future value of an annuity due. We're going to check that out. That's going to be in 8 periods, and it comes out going through this arithmetic. Table 5.3, we're going to have this factor for 8 periods at 6%. Multiplied times 6% gives me the 8393.06. Okay, that looks like a good place to stop this video. And when we return, we'll take a look at more problems. Until that time, bye for now.